cause a small issue. That is the challenge of sequential document approval. In the real world, many critical process requires a document to sign a strict and chronological order. For example, a corporate expense report may be first signed by the employee, the manager, and director. The rule is very simple. That is, the next person cannot sign until the previous one has done. The traditional system relies on the trusted third-party TTP. And it will use to manage your identities and signing order. However, it will increase some critical vulnerabilities, such as the sync point of the failure, place to prompt to data manipulation, and security breaches. Some related cryptography may be inefficient, such as ordered multi-signature. Ordered multi-signature are usually designed for the network routing. Where the number of the routers may be large. However, we cannot imagine that the document retriever needs more than 10 persons to sign a document. Most existing other multi-signature usually computational expensive because it usually will verify all the previous signer signatures. Our mutation and solution has been two respects. The first one is the blockchain platform. We use blockchain to replace TTP. We use 3 smart contracts to registering the signer's identities, define document request workflow, and verify storing the final documents. The second, we propose a novel ID-based order signature IDS scheme. It will properly ordered and high efficient. It supports on-chain batch verification. Because if the verification of the signature on-chain, as we know, verify one signature in Bitcoin is about several dollars. It may be not very, not expensive, but the number of the signature increase, the cost will be heavy. This is a traditional system. The first signer will send the approval to TTP, and then TTP will forward to the signer 2, and the signer 2 will send approval to TTP, and then forward to next. This is our hybrid architecture. Our architecture, the first part is on-chain part, work as a trust offer. This consists of the smart contracts, handle the critical tasks such as rules, identity, and final verifications. The off-chain part is efficiency layer. This is step-by-step signing happens between all users directly. This is off-chain signing process. This is on-chain setup. So the on-chain component consists of the 3 smart contracts. The first is registration contract. This is act as a phone book for the all participants. The second contract is a task. It's a request task contract, which role is task initiation. It will define the document who will be signed and the signing order, and broadcast to the relevant signers. The final smart contract is the verification contract, whose role is the final audit and storage and stores the document with hash and the signatures on the blockchain. Here is this table. It gives a comparison between the traditional system and our blockchain-based system. Let's see our main building block of the IBOS scheme. This identity-based ordered signature scheme consists of 4 algorithms. The first setup, which is system initialization algorithm. The second is extract, which is a key generation. The other sign algorithm is a sequential signing process. It was efficient off-chain signing. The last one is batch verify. Batch verify is crucial for the efficient on-chain use. Our innovation for this scheme is creating a signature chain. So the unsigner only to verify the previous N-1 signature, and then sign a new message M1, which includes the previous signature. This is the old way. The signer will verify all the previous signature. Our IBO scheme based on the case IBS signature. This signature here is the master. Y and X is his master public and the private key pair, and the R is the commitment, and S is the signature. Here is the verification caution. Then our IBOS scheme, the setup algorithm and the extract algorithm is the same as the case scheme. Then for the order signing algorithm, for the first signer, he or she will run the case scheme and sign the message document and generate the first signature. And then the signature 2 will verify the first one's signature, and then he will sign M2. M2 includes the document and the hash value of the S1, and generate the sigma 2. Then for the last one, last signer will just verify the previous signature and signs the new signature, new message, which includes the hash value of the S minus 1. So it will generate a set of signatures, sigma I. In the last algorithm, batch verify, the verify will recover n messages and a set of signatures. Then he will choose an important value. This row I is important. Row I is randomly for choose, and then use one equation to complete the verification by using the row I. Only use one equation. So we simply prove for our scheme that adversary can, if an adversary can break our scheme, then it will lead to break up the case scheme. We will not discuss it in detail. Now we discuss the rule of the random row I. This is important for the batch verify. If an attacker wants to insert one invalid signature sigma j star to the set of signature state, then our batch verifying mechanism can detect this attack let's see. If we set a signature to G2 alpha I, hash value of the message G2 beta I, hash value of, oh, sorry, this is wrong. So from the equation, we can compute rho J as this. That means if the rho J is chosen by the verifier, that means if the attacker want to insert invalid signature sigma J, it will guess the correct rho J. It must correct rho J because this rho J is chosen by the verifier. So, but the probability is very negligible. This makes this attack incredible. So this number is important. Our IPO scheme from dual efficiency. The first is signing is off-chain signing efficiency, because each signer only performs only one verification. The other is the on-chain of verification, because this scheme supports batch verification. This will greatly reduce on-chain gas fees. Let's see the on-chain smart contract in detail. This is the registration contract. This contract mapping from the blockchain, unique blockchain address to the signer's identity information, such as the IP address and identity informations. The key function in this contract is registration. It will write the new signers to the blockchain and get identify address. The second contract document request, the key logic is that it will set up the signing order list one by one, and then broadcast to the signer group. The last contract, the key logic is it will retrieve the required signers' identities from the signing order list, and then generate the important random number row, and then it will verify or realize the batch rate verified. And finally, we will store the new. The security for our system is from the resisting the corruption attacks and fundamental blockchain security. We in the corruption attacks, if the adversary corrupts the signer I+1 to insert in or dishonest signer I, we can resist due to the security of the batch verified. That is also because of the number. For the fundamental security of the blockchain is we can create as many as nodes as possible to join the blockchain. Is evaluation. This picture shows the off-chain of signing. The blue line is our scheme. This picture shows the on-chain gas corruption. That's conclusion. We propose this system and I will speak. Thanks.